Hello, my name is Amaya John, and I'll be explaining my assignment 6 code. Okay. Okay. So this is my H file. Here we just declared the template. And it's of class type T. And it's of type T. And then we have our class, and inside it we have our default constructor, our destructor, rule of 3, copy constructor, and deep copy assignment overload. And then we have our two functions enqueue and dequeue, which are adding and removing things from the queue. And we have our private data members, our typical size and capacity, and we have a double pointer called array because we have a pointer that points to the array, which then points to the elements of type T, the elements inside type T. Okay. In our HPP file, we just have the definitions, of course. So for our default constructor, we're setting the size equal to 0 and our capacity at 5. And then we have our dynamic array of size capacity. And we have like a pointer here because it's a double pointer. Yeah, of type T. And here we have our destructor, which is deleting the elements. It's deleting the elements or objects pointing to T. And then it's deleting the actual array of pointers afterwards. And then we have our copy constructor, which is copying all the static information first, and then is gonna copy it's gonna do another copy, but dynamically. So it's gonna take the objects that are in the p dot array, which is like what we're copying into, and then it's gonna copy those contents into the original array. Like take what we want to copy into the original array. And then our operator overload is doing the same thing. It's also checking for self-assignment right here, and doing the static copy and then the dynamic copy. And the reason it's deleting the array, the original array, is because before creating a new array is because like the array already exists when we do an assignment overload. There's usually an object that already exists, so we have to delete that object before we make a copy of it. Yeah. And then for our enqueue, it's similar to the growth algorithm where we create a temporary array and then we copy the original array into the temporary array, and then we delete the original array and then assign the pointer of the temporary array to the original array. That only happens if the size happens to be greater than the capacity. And then if the size is not greater than the capacity, then we're gonna store that object into the array, the array here as the size increments. And that will get added to the top of the queue because a queue, yeah. I mean, to the end of the queue, sorry, it'll be added to the end of the queue. And for the dequeue, that's where we talk about the top where we're returning well, first we're checking to see if there's anything in the queue. And if there isn't anything in the queue, then we're gonna take from what's in the top and delete that, which is why we have the array starting at 0, because that's the top of the queue. And then we're gonna shift the elements over after it's been deleted to the front. And then we're gonna decrement the size to account for what we just deleted, which was the first element of the array. And then it's gonna return that and it's gonna keep going until there's nothing left in the array. And we'll then return null pointer because that means there's nothing else there. Yep. And then for our main function, here we're just adding, we have like 4 different queues. 2 of them are ints and then 2 of them are doubles. So here we're demonstrating, we're putting the values 1, 2, that should be 3, sorry. 1, 2, 4, 5, and 6 into Q1. And then we're copying, we're doing the deep copy assignment because Q2 was already created, so therefore we're just gonna use the equal sign for it. Then for Q3, this is for doubles, so we can use like the decimals. And here, this is demonstrating the deep copy constructor because we're creating Q4 here, and then we're assigning, well, we're assigning Q3 into Q4 that was just created right here. And then here, we're just printing out what was in Q1. And in this case, what was deleted from Q1, because we're calling, yeah. Okay, we're like printing what was just deleted, so we have a pointer that points to what was just removed from the queue, and then our counter is keeping track of what the index is. So it's going to say at 1, at index 1, blank was deleted. So in this case, 1 was deleted. So that lets you know like it's gone, and it'll keep going until there's nothing left to delete in the queue, and that applies for like every queue. In this case, but for Q3 and Q4, they're doubles instead of ints. And then here we're just checking to make sure that the queues are empty and they should return 0. Yep. So I can show you my code now. Okay. Okay, so this is Q1, 1, 2, 4, 5, 6, which we put it in there. And then these are the indexes. So it's been like, that's as it's going through and deleting everything, we're just showing what's been deleted. And the same thing, how we copied Q1 to Q2, this is the same, we can see it's the same exact thing. And then the same for Q3 and Q4, they're the same exact thing. And just showing like what's in the queue or what's been deleted from the queue in this case. And then here at the bottom, we're just checking to make sure that each queue is empty, and it is because it's returning 0. And yeah, that's the end. Thank you for watching.